Welcome to the Quantum to Cosmic YouTube channel with me, Ollie. Welcome back to this tutorial series on functions. This series is aimed at first year undergraduate university students or those who are just interested. Whether you just need a refresher on these topics or are learning them for the first time, you're in the right place. Today we are continuing with integration, looking at the fundamental theorem of calculus, that is, how integration and differentiation relate. So if you're ready to learn, then let's get into it. To put this formally into words, this would be stating that integration is the inverse of differentiation. That is to say that if we define a function f of x equal to the integral from a fixed a, so this constant that's fixed, up to our variable x of this other function, small f of u, du, where u is our dummy variable. This is an indefinite integral because x has been undefined as some constant. And if that is the case, then df, big F, by dx is little f of x. And that's all well and good, but I'll go through the proof of it next to show you how this is definitely true. Let's start by just writing down our definition of a derivative. To differentiate f with respect to x, we take the limit of delta x tending to 0 of f of x plus delta x minus f of x all divided by delta x. And this is just our definition, and see an earlier video if you want to see where that comes from. And from here what we can do is substitute the condition of our if statement here into both these f, big F's of x. So this f of x plus delta x will become this indefinite integral of f of u du, where we have our fixed a, just a random constant, it's arbitrary what that is, and then our top limit of x plus delta x, as that is what it is a function of. And then for our f of x, it's the same principle, but just our top limit is x instead. Then we can use the addition rule, or in this case subtraction rule, of integrals to find what the combination of these two are. So if we look at this graph here, this integral represents this box, like that. And this integral represents the unshaded box. And so the combination of those two results in this shaded area. Having this big area minus this small area, and we're left with obviously the shaded area. So what is that shaded area in terms of an integral? Well, it's just the integral from x to x plus delta x of the same function f of u. What does our limit as delta x tends to 0 mean graphically? All we're doing is decreasing delta x so that this line will inch closer and closer towards x, and in the limit as it tends to 0, it'll just be a line on x. And so this integral will just become from x to x in a sense, and so we can just write f of x and then times by our distance across delta x, because as you get smaller and smaller, you're not going to have any dependency on the function in terms of delta x. It's just going to be a small distance, and so you can just multiply the two, and then we're still dividing by delta x. And so what happens is those will cancel, and we're just left with f of x in the limit as delta x tends to 0. And that is what we were searching for, that d big F by dx is equal to small f of x. And that's dependent on the case that this is true. In the previous definition of f of x, we stated how a is this fixed value that is arbitrary. And this is meaning that an arbitrary constant can be added to our f of x, because when it comes to differentiating it, that added constant will just become plus 0. So we'll just be still left with small f of x. And you can look at this as, in one limit, we're having f of x, big F of x, or another function, g of x, minus g of a. And that whole thing together is equal to our big f of x. And that g of a is just going to become differentiated out when we perform the derivative of df by dx. And this is why it's called an indefinite integral. In comparison, a definite integral is where our integration is from two fixed constants, a to b. Again, we can do it of f of u du, and this would just be f of b minus f of a, which has a definite answer, as that is just a number. Whereas here, it's indefinite because it still depends on x. Today, we have looked at the fundamental theorem of calculus. In the next video, we'll be covering infinite and improper integrals. So if you want to learn more, I'll see you in the next one. If you learnt something new or just enjoyed this video, please hit the like button and don't forget to subscribe and tap the notification bell to stay updated on new videos. In the meantime, stay curious and I'll see you in the next one.